Hi guys, so this is a video to show how to start a minimalistic project with the dsPIC33AK and MCLV48V development board. Firstly, you will have to download Scilab, which you can find instructions in the beginning of the video. After you install Scilab, you will have to install the X2C, the right X2C version. So in this case, you will have to install the version 6.5 341990 builds. So how do we do that? We go X2C. Then we open the LCM website. We go to downloads and we go down. We open nightly builds and we download the version that was indicated by clicking on it. It will download the executable that I downloaded previously. Then we open it. We have the welcome. We will accept. We will select the microchip components. And since we already have MPLAB, we will deselect the automatic download of MPLAB 6.0. Since you will have MPLAB 6.2. If you already have the examples, you don't need to download them again. If you don't, then leave everything selected. After that, we click Next. We'll have to indicate the harmony path. For the harmony path, we'll have to open MPLAB and check where is our harmony path. To check the harmony path, we will have to go to Tools, Options, Plugins, and then here we can see the harmony path. We'll copy it and paste it here. After that, we'll click Next, add Scilab to the user path, Next, and install. Since I already have it installed, I will not do it again. After it was installed, it will be located in the LCM folder in our C drive. So we open Scilab and we look for the installation. Windows C, LCM, X2C, and our installation. Click Open. We go to System, Scilab, Scripts. We go down and we go to setup.ec. We click on it and then we right-click and click Execute in Scilab. Now it will have executed the script. It will ask us to close. We'll close Scilab. We will open it again to complete installation. And as you see, it will be completing the installation right now. After this is done, we will not have to do it anymore because this will always be executed at opening of Scilab. After this, we will go to MPLAB. We'll open the file that you downloaded from the Git repository. So open project and you will select the file that you want to open. You will have to make sure that it's in bold. So to do that, you have to set it as main project. After that, you go to source files and main.c and you see how the code was written. And you can also go to X2C and X2C main.c where you can actually see the calls to the update import of the X2C model and the update output of the X2C model. And here, how the X2C model gets refreshed, in this case, with a timer callback. As we have seen all this, we will clean and build the project. And after that, we will program the board by clicking here and then make and program the device main project. In this case, it will show the tool to use for programming and you will click OK and program the board. I will do so promptly. After connecting the board, we can actually program it. So let's go programming the board by clicking here and it will start programming the board. When it gets programmed, we will see the two LEDs blinking, and if you click in the switch, we'll be able to turn on and turn off LED 3. And by moving the potentiometer, we will be able to change the blinking frequency. But what if we want to use the XCOS model? So we go here and we find the directory. In my case, I already put the directory in the main.c file here, which basically we copy here, will be here. So this directory is found in the project, the main project, X2C code, and then here. You have to click and execute in Scilab. In this way, it will open the XCOS model. After opening the X2C model, we can start communicator by double-clicking on it. It will show us this, and it will connect to the board. In this case, it didn't connect because I didn't select right word port, so I will click refresh port and connect to the right port. Now that's connected, we can transform the model and push to communicator. We can transform the model and push to communicator also if the board is not connected. If we want updated code and then to reprogram the board, by clicking here, we'll be able to generate code and then to reprogram the board, we'll use MPLab. But now the interesting thing is that we can use the live scope to see what's going on with the many in and out ports. So I click sample and I can see live the blinking of the LED. And if I click in the switch button, we'll see that the switch will turn on and off since I'm pushing it on and off. Same thing can be done here live. So if we keep connected, we can change parameters from these blocks and see live what changing parameters live will do to the model. So for example, here I will change gain and I can see that just by changing this value, the LED will start blinking faster and slower. This code is not re-uploaded into the board. So if we do modifications to these blocks, then we always have to regenerate the code here and then reprogram the board with MPLab. But for doing changes and doing rapid prototyping, this is a great way to change parameters live. And yeah, that's it. Hope you liked the video. Thank you for watching.